Introduction to Engineering Drawing. In this video, we will discuss drawing, engineering drawing, applications of engineering drawing, instruments used in engineering drawing, and different types of lines used in engineering drawing. Drawing. Drawing is a graphical language that communicates ideas and information from one mind to another. Or, the graphical representation of any object or idea can be termed as drawing. A drawing can be prepared either using a free hand, or using engineering instruments, or using a computer program. Engineering drawing. An engineering drawing is a type of technical drawing used to fully and clearly define requirements and capture all the geometric features of a product, such as dimensions, for engineering products. Applications of engineering drawing. Drawing is used in manufacturing of all automobiles. Drawing is used in constructions. Drawing plays a vital role in engineering, and it is essential to our daily life. For example, construction of rockets, missiles, ACs, etc. Initially, they should need drawing to come out as a final output. Instruments used in engineering drawing. Drawing board, drawing sheet, mini drafter, T-square, compass, divider, set squares, protractor, French curves, pencils, eraser. Let us describe each and every drawing instrument in detail. Drawing board. Drawing board is generally made of softwood and it is in a rectangular shape. It is used to support the drawing sheet, so the size of the board is made according to the size of the drawing sheet. Drawing sheet. Drawing sheet is a white paper on which an object is drawn, which is available in various sizes. To fix the drawing sheet to the board, clamps, plasters, paper holders are used. Mini drafter. Mini drafter is an instrument used for multiple functions in drawing. It contains two arms, which are adjustable to required angle, and at the end of the lower arm, a scale set is attached. This instrument is fixed to the drawing board at one edge with the help of screw provided for the drafter. T-square. T-square is used to draw horizontal and vertical lines on a drawing sheet. The edge of the head is in uniform level and attached to the edge of the board. The working edge is used to draw lines anywhere on the sheet by moving the instrument top to bottom. Compass. Compass is used to draw an arc or circle with known dimensions on engineering drawing. Divider. The divider looks like a compass, but the difference is the two legs of the divider are provided with needles. This is used to divide a line or curve into equal parts. It is also used to check the measurements. Set squares. Set squares are used to draw lines with an angle between them. In most of the structures, 30, 45, 60, and 90-degree lines are most common. So, set squares make the work easier for this type of drawing. Generally, set squares are of two types. One is a 45-degree set square and another one is a 30 to 60-degree set square. Protractor. Protractor is used to draw and measure the angles of lines in the drawing. It is in the shape of a semicircle, and the edge of the semicircle part consists of reading with 1 degree accuracy. The bottom line joins the 0 degree to the 180 degree. The center of this bottom line is marked as O or C, from which the angles are measured. French curves. French curves are made of plastic and they have irregular shapes. Sometimes, the drawing requires irregular curves, or shapes, or arcs, which cannot be drawn using compass. In that case, French curves are suitable. Pencils. Pencil is used to draw on paper. Any type of pencil is not suitable for drawing. There are some limitations. The drawing appearance should be very neat and understandable. Every line of the drawing should indicate its importance. The following pencils are used in engineering drawings. 3H pencil, 2H pencil, H pencil, HB pencil. Eraser. Eraser is used to remove the lines or spots which are drawn by mistake or with wrong measurements. Next, we will see different types of lines used in drawing to indicate different parts of an object. Continuous thick line. This line is used to display outlines and edges of the main drawing. Continuous thin line. This line is used for extensions, dimensions, projections, hatching, leader, etc. Continuous thin, free hand line. This line is used to show short break, irregular boundaries. Thin line with zigzags. This line is used to show a long break. Dash line. This line is used to show hidden edges of the main object. Chain thin line. This line is used to represent central lines for circles and arcs. Chain thin line with thick at the ends. This line is used to represent the location of a cutting plane. In this video, we have discussed the introduction to engineering drawing, instruments used in engineering drawing, types of lines used in engineering drawing. In this video, we will introduce the scales in engineering drawing. Do you know how the drawings of huge structures, like buildings, bridges, and complex machines, are prepared? How a 20-feet building is represented by using 10 centimeters long lines on a building plan sheet. What is that mathematical parameter which allows you to convert dimensions so that they can properly fit in a drawing sheet? That mathematical parameter is nothing but scales. Well, let us see what a scale represents. We know that we can represent every object in the real world by drawing them on a piece of paper. For example, let us consider a wristwatch. The internal structure of wristwatches is made up of extremely small gears, of magnitude about 1 millimeter. To represent them on paper, we need to enlarge them according to their actual size. Can we represent large objects like a building, an aeroplane, with actual size? The answer is no, right? We can't represent large objects on paper with their actual sizes. We need to reduce the actual size to represent them on paper. So, while drawing objects on a paper, there is a need to reduce or enlarge the actual size. The proportion by which the drawing of an object is reduced or enlarged is called the scale of drawing. The scale is defined as the ratio of the linear dimensions of the object as represented in a drawing to the actual dimensions of the same object. It is represented as representative fraction or representative factor (RF). Simply, it is the ratio of the length of an object on drawing to the actual length of the object. For example, if we represent a 2 meters long wire as a 2 centimeters long line, then the representative factor will be the ratio of the length of the wire in drawing to the actual length of the wire, which further equals 2 centimeters by 200 centimeters, which equals 1 by 100. We have 3 types of drawings: full-sized drawings, reduced-size drawings, enlarged-size drawings. If drawings are drawn with the same size as the original objects, then they are called full-sized drawings. For a full-size drawing, the representative factor is 1:1. For example, RF equals 1 centimeter to 1 centimeter. That means a 1 centimeter original length is represented as the same 1 centimeter in our drawing. If drawings are drawn with reduced size of the original objects, then they are called reduced-size drawings. For a reduced-size drawing, the RF is 1:y. Here, y is greater than 1. For example, RF equals 1 centimeter to 100 centimeters. That is, a 100 centimeters length is represented as 1 centimeter in our drawing. For example, bridges, buildings, ships. If drawings are drawn with enlarged size of the original objects, then they are called enlarged size drawings. For an enlarged size drawing, the RF is x:1. Here, x is greater than 1. For example, RF equals 10 centimeters to 1 centimeter. That is, a 1 cm length is represented as 10 cm in our drawing. For example, screws, gears, small electronic gadgets. The common scales recommended while drawing are. In this video, we have introduced the scales in engineering drawing.